to our stream. So we planned actually a lot of activities for today, but let's see how it goes. The weather has changed drastically lately. But anyway, let me first introduce myself. I'm Vasily. I'm a senior scientist at VTT, Technical Research Center of Finland. My main expertise is radio communications, antennas, and actually drones started as my hobby, but I'm happy that they started to be a part of my research work. And we have like Jarko. Let's see, just because the messages we have some issues. But as I was mentioning, so we have the weather forecast was planned to be like sunny and very warm today, but it's almost started raining now, and everything is like clouds everywhere. So that's actually but that happens when you do live streams. But anyway, we will try to show you as much as possible and as many things as we planned today. So let's see if Jarko's microphone is working now. I hope you have the sound.
If I have sound. All right, I'm Jarko Saarinen. I work as a research technician in VTT, and I work at the maritime part of VTT, but I drifted along the years to drone flying and drone operating, and that's the short of it. And I was planning to pilot the Aurelia drone, the bigger one, this one, today, but it seems like that we are not able to fly it today.
But we will actually we will go through why and how we make these decisions and so on. But
yes.
Anyway, welcome to the stream, and we really hope that you will enjoy it. Don't forget, if you have any questions, just to drop them in the comments, and then we will try to reply them at the end of the stream. And here you can see our airfield, how we operate actually, and now we are in the airfield or airport zone, in a small airport. And it's actually interesting that you do drone testing in the airports where airplanes flying, but it's actually much easier to organize flights here and coordinate with manned aviation. So that's actually the place where we are. And I think on the image from the drone you could see that there is quite strong wind already, and we have gusts, like we had them up to 10 meters just before the stream started. Anyway, let's talk first about the drone applications, and maybe the first one which comes to our mind would be cinematography. So maybe I need to mention here, so first we want to go through drone applications, show you some examples of real drone work, and then also cover some part of our aerial project where we have done channel measurements between drone and ground. But just to make it more interesting for you, we want also to expand a little bit and just give you an overview of like the whole drone field, hopefully whole one, but at least part of it. And let's start with applications, as I mentioned. So cinematography would be one, and what I can show you now is actually, for example, how the drones are used in cinematography. So if you come to this, for example, one of the YouTube channels, maybe you can recognize the guy here on the cover, and then we can just start some video. So that's actually how you can use drones. And of course, in filming industry, the drones are existing already for quite a long time, and they are used in many movies and so on to get like excellent shots which are not reachable from the ground. So this is like just one short example of application of drone applications. But besides cinematography, there are many more applications, and I believe it will just come now so that you will see it. For example, we have had this fireman project where we studied wildfires using drones. We obtained a lot of data and a lot of collections. So as I mentioned, yes, we started with cinematography, and here you can see some nice castles, and here also some views from drones in Finland. Actually, let us know if you fly drones as your hobby, and if you do filming with drones. But let's listen a little bit about this fireman project and how we utilize that results.
for wildfire management. We put a lot of emphasis on developing new flavors of swarm intelligence that would allow us to basically provide the right kind of information to the firefighters in real time. So for that we have developed techniques that would allow the UAVs to operate as an intelligent collective, which is a swarm, to discover a fire and then to monitor its progression over time, to operate entirely autonomously without any human input.
The drone swarm part includes a swarm of drones where you have, let's say, 5 to 10 drones can be even used to detect where the smoke or the fire is, and then call the rest of the swarm to the side of that smoke to see what is the source of the fires. In case it's a wildfire, obviously, then those drones included in the swarm will be monitoring the area from different angles with their sensors and cameras. And one thing that we have noticed is that if you use thermal imaging cameras, it's much easier to see through the smoke where the fire front is advancing. So that is really useful information for the incident commander of the wildfire situation.
Recently we have been participating in demonstration of the results of the Fireman project funded by Academy of Finland, and the project is related to using various technologies and drones in detecting and monitoring wildfires.
Yes, and that was really nice opportunity for us for also testing our radar technology in these kind of conditions. So one of the advantages of using radar is that basically you can see through smoke and also operate it in very different, let's say, difficult or challenging weather conditions. And for example, these kind of rescue operations, it might have a, say, benefit over the other sensor technologies.
So basically, the radar can see through the smoke and can be utilized for search and rescue operations. So finding people lost in the forest which caught fire, and so on. And it can be also beneficial if you compare it with the LiDAR technology. Wildfires and monitoring wildfires. We also have done research related to waste detection, and basically we investigated methods how we can utilize also cameras and infrared cameras and hyperspectral cameras and various sensors on the drone in order to detect the floating waste, which can be actually beneficial to clean up our oceans and seas. And here you can see the example of the drone equipped with a camera, and which just captures like this artificially placed waste on a small pond where we did testing. And these results are analyzed, interpreted, and then based on the data we can create some algorithms actually allowing us to distinguish it and to identify the waste. Also, as you have seen about the wildfires, here I wanted just to show you an example of the drones flying around where the wildfires happening. And here we also used infrared camera just to detect the source of fire and see because basically on the optical sensor, so just on a normal image you see a lot of smoke, but you don't see really the sources of the fire, while with this thermal image you can actually see the fire itself and where it is concentrated. And these data can also be collected and used for further analysis and developing various algorithms. Besides this, what you just have seen, we will be actually flying today still. So we did these flights with a small drone, with a Mavic drone, but we will be flying also with a big one and show you this thermal imaging and how it can be interpreted and how we fly and operate this drone. But before we switch to the thermal imaging, actually we wanted to show you also how the drone technology is evolving. And basically Jarkko is now wearing augmented reality glasses provided by Narki Labs So, and the main idea of these glasses is, so we have actually two demos which we wanted to show, but particularly this one, it includes a simulator inside. So this simulator can be used for drone training or for pilot training and training for piloting drones and various scenarios actually. So for example, teams, firefighters, they can test this scenario and see how it works. So now actually you should be able to see, just if you give me a second, we will put it online. So now you should be able to see what Jarkko is seeing. So currently he's in virtual reality, and basically you can see also the drone, that the drone is just on the landing pad. So he's like in the forest. So this application is that we need to find some fire source in the forest, but basically Jarkko will continue here.
Yeah, looks a little bit warmer environment here right now, but as you can see, I'm not sure if there's some sort of delay on the stream, but right here you have picture, the same picture that you would have on the remote controller right here, which gives you the same information of the flight as a real drone would do. Then there's a map of the area, and it's very straightforward. You can look around, see the area, and now we figured out that we would take off with the drone, and there's a wildfire somewhere around this place, and for firefighters or rescue services, drone operations like this is really good good tool, because finding in this kind of environment of forest, finding the actual fire or persons that might be missing would be rather difficult. Let me just close this one window here. So there you can actually see we took off, and there you can see on that big screen there's the fire itself. So we will fly towards it. We can estimate on the view that you are seeing right now, we can estimate how high the actual smoke plume is going. Now I'm some technical issues. I lost the image on the goggles itself. It froze up. It could be that there's some issues also with the cold weather.
Yes, we got actually quite a lot of also interference issues here
Okay,
lately, but
I'll try to restart it, but if you have something else, then go ahead.
okay, anyway, maybe meanwhile Jarkko tries to reset it or restart it. Let's see. The second what we wanted to show, besides augmented reality and actually training pilots, there is also an option to use augmented reality for real drone operations, and in particular now you can see that I'm wearing these augmented reality glasses. They actually see through, so basically I can see everything around me, and at the same time I have an image of the glasses. I will try to put it on as well. So once we launch the app here, so this is AirHot app, allowing us to connect to the drone and also operate it and get all the telemetry data, all the information here in front of you. So yes, before we go to before you start seeing what I see actually in the glasses, first I will, or actually maybe you can even already see it now. It's coming. So I will try to set up the drone position. So I will go to the drone now. So basically my glasses are connected now to the drone remote controller. So hit it and get it on map. So give me a second. Do I need to change mic? Now it's good. Okay. So yeah, sorry, some technical issues. Yeah, I will try not to move fast. So sorry, so that you do not get dizzy. But basically, what we see here, and that's the main idea of this lens and then this product, is actually that you can always keep visual line of sight to the drone. So I have a map and I see myself and the drone here on the map. Here I have another map which will be moving and attached to the drone when it is flying. And here I see the camera feed from the drone itself. So if I take off now, you should be able to see how I can track the drone. I'm taking off, and this is the main point of the whole like air HUD here. So you don't need to watch actually the remote control, even though you have all the telemetry here and all the images here. What you can do, you can just see here through augmented reality the location on the map, the drone. You can see the location of the pilot, you can see the lateral distance, you can see the height, which is like 4.4 meters now. You can see heading information of the drone, battery levels, and so on, when you need to return back to home, and so on. So currently we have on the drone installed thermal camera. So I will try to switch to the thermal camera, and that's actually coming back to the applications which we were discussing. So for example here,
may I
go ahead.
Yes, it looks like there is some more technical issues, but it's part of the deal. Doing drone operations.
Hopefully, I hope you can hear me. And anyway, so in this, what I was saying, that in this application actually we can use the drone for search and rescue operations, and for example try to find people in the forest using the thermal image and thermal camera. And currently I'm just flying using this augmented reality, so that I see the map and all the image from the drone. So actually I can also try to watch the other direction. There are like some houses, you can see some heat coming from them, and then some other objects over there. Actually just before the stream we were practicing, and we could see some deers on the field. That was pretty interesting, so you can also define or identify those. And yes, currently I'm quite low altitude, but just showing you and giving you the idea how you can utilize this thermal imaging. So you can also do, for example, you can of course see the car, which is quite warm, and you can also do inspection of the houses and see how, for example, where is the leakage of the heat, where it comes from. And at the same time, if you fly in the city, actually this augmented reality can be super beneficial, because you see the drone, you see all environment around you, and at the same time you get all necessary information for the pilot, like distances, degrees, battery levels, satellites, heights, altitudes, and so on. And you can also, if I go here and switch the big map, I should be able to see the big map here, like in front of me. And you can also see there are some 3D objects. So if you were in the city, you would be able to see a lot of buildings around you. Now we are in the field, so it's just several, behind that highway, and also you can see this runway where we are, like on the side of the runway. But this is quite interesting because you can also see the limited airspaces on this map. So once you operate, you can actually realize where you are allowed to fly, where you are not allowed to fly, where you should go and where you should not go. And of course you can see other pilots, and you can drop markers on the map and so on. Of course, all this depends on the application that you are using, but for drone flights, augmented reality actually brings a lot of benefits. So now I will be coming back and landing the drone, and after that we will actually discuss like other topics which we had in mind for today. Landing. Yes, as I was mentioning, what we wanted to show you today, we wanted to show you and focus on the aerial project. But due to the weather, as Jarkko mentioned, we are not able to perform flights. It's also a little bit of rain now, and we have quite sensitive RF equipment, but we don't want to take risk now. And currently, as you can see, actually we have a van here behind us. This is our mobile laboratory where we keep all the tools, where we have like places where we can fix drones. It's actually heated inside. We have 5G exit points. We have safety lights on the car so that we can be visible if needed. Actually, on the other side you can see the weather station. We use this weather station to collect weather data, and we do it during the flights also. So now I'm just trying to give you also an idea, so we can see the temperatures, we can see the wind, we can see gusts and so on, and we can get very accurate weather just for this particular moment and this particular place. And this is actually what we usually use in our drone operations. And also this is like the big drone now, which Jarkko has in front of him. That drone can carry 8-kilogram payload. And what we have done in an aerial project, actually an aerial project, maybe it's necessary to mention that it's a joint project between VTT and NYU, United States. And this project is funded by Academy of Finland and National Science Foundation. And the idea of that project was to develop a measurement system for air-to-ground channel measurements. And based on that measurement results, actually, we would like to continue with the simulations and create channel models, so that we can calibrate and create channel models, basically utilized for building any wireless system. And this drone, we have the RF equipment prepared, which is just here. So we will be just showing you the nodes. So we don't want to keep it outside for long, because this is not waterproof, not water protected. But what we have here, you may have actually seen it in our previous streams, but what we have here, we have two nodes, transmitter and receiver node. And this is software defined radio based measurement equipment. It operates at 60 gigahertz and 28 gigahertz, and we have antenna array, actually receiver and transmitter antenna array here on front, so the both nodes basically are identical. So we have also internal batteries, we have PC powering and recording everything. And actually you can see that this node, this is like TX node or ground node, which we use on the ground. We usually mount it on the car, and it has a gimbal, so it can be stabilized and rotated to any direction we need. But besides mechanical rotation, we can also do beam steering utilizing the antenna arrays here. So the same actually comes to the RX, which is just here. So it's identical node, as I mentioned. We also mount it on the gimbal, and actually the gimbal is mounted below this Aurelia drone. So whenever we mount it there, when we take off, we can actually put the landing skid up, and we can rotate freely the payload. And besides mechanical adjustments, we can do also beam steering with the antenna arrays actually. So as I was mentioning, so we have quite bad weather, so unfortunately we are not able to do this flight with the equipment which we wanted to show you. But anyway, we will be showing later some results of what we achieved and so on. Of course, this measurement system can be utilized not only for air to ground, but ground to ground or car to car communication, ground or air to robot communication, whatever you name it. And we are collecting actually a lot of empirical data using this equipment, which we will be processing and publishing as an open information. Yes, maybe we can just put this one back and not keep it like so long time under the rain, or under this small rain. And yes, as we were mentioning actually about the flying, so I thought that it may be interesting to point it out. So even if the weather is good, we come to the flight, and for example the pilot is usually who makes the decision in the end. So the pilot can say, okay, I'm not flying now. And there can be various reasons for that. I don't know, feeling bad, feeling something is wrong. I'm not talking about superstition, but anyway, something wrong, like some problems with the hardware and so on. And usually the pilot makes the decision if he's going to fly with the drone and with the payload. So, and usually that's kind of the final and last decision before the flight happens. And currently I think Jarkko was first one today to say that it's quite risky to fly. I was still hoping that we will get better weather, but no, and just before the stream we agreed that we can fly some other drones, but
it's a compilation of things that doesn't seem right now. It's participation of little rain and pretty high winds for the payload.
Yes, and actually, since I was mentioning this aerial project, we have a special video about that aerial project, which you will see just now, and get the idea what is the idea of the project, what we were planning to do there, and so on.
We are already living in smart cities where new technological services are constantly emerging. For instance, robot deliveries have become commonplace. You can order food or drinks to your home, and a robot will deliver them. Additionally, new technologies are enhancing urban safety. Unmanned aerial systems integrated with vehicles offer significant advantages. Drones can play a crucial role in assisting first responders, such as firefighters, paramedics, and the police officers, by providing them with real-time information. For example, a drone can fly ahead of an ambulance to monitor traffic conditions and suggest alternate routes to avoid congestion, ensuring that help arrives as quickly as possible. Similarly, drones can provide firefighters with aerial views of a fire, helping them assess the situation and plan their response more effectively.
We all know how important wireless communications is in your daily life. Imagine trying to go the whole day without your cell phone. Wireless communications can unlock all sorts of possibilities for drones as well.
Considering the mentioned applications, this project involves designing and building a channel measurement system that can be integrated into a flying vehicle. We are also developing custom software for data acquisition and equipment control.
Aerial is a project aiming at developing novel channel models at millimeter wave frequencies, and we want to study the communication between the flying platforms like drones, for example, and ground units, robots, cars and vehicles.
And this area of wireless characterization in the air is relatively unexplored, which is why this project is so important. We're setting the foundation of aerial wireless communication.
Fundamental is understanding how signals propagate, that is, how they move in the air and how they interact with other obstacles like buildings in the environment.
Another area where the results of our project will be valuable is in the integration and seamless coordination between drones and ground robots. The drone can monitor the situation on the street, detect accidents, or determine if assistance is required. It can then dispatch the ground robot equipped with a medical kit or defibrillator to the location, thereby supporting first responders and enabling faster delivery of medical supplies. Furthermore, this technology can be scaled and adapted for various emergency scenarios, whether it's delivering medical supplies during a natural disaster, assisting in search and rescue operations, or supporting routine emergency services.
Project Aerial isn't just about pushing boundaries. It's about erasing them and making high-speed, reliable communication a reality for drones everywhere.
So that was the idea behind Aerial. Basically, yes, as I was saying, so we want to study radio channels, we want to develop new applications, and for example, communication between drone and ground robots. And as you can see now that we didn't fly with the equipment, actually measurements are usually a very tricky part, and it's because there are a lot of factors affecting the measurement. So even if the weather was good, we would be flying with the equipment, we would not be doing real measurements, but so far we wanted just to give you the idea how it goes and how the equipment looks like, and we just put it like, you know, give a general overview of our work. And actually, let's maybe come back to the applications and show how we already performed measurements. So there is what we did actually. So we did a lot of test measurements in Belgium, and that test measurements we have done them between the cars and between the drone and the car, and it should be running on the video now. You should see it. And besides that, we have done as I was mentioning. So now you should be able to see it. So again, applications. So, and this is our flight in the city center. So we are testing various sensors, and we are testing actually these developed applications, communication between drone and ground nodes. And actually this is what our measurements are about. So we have done these test measurements in Kalasatama, in Helsinki city center. Here you can see just the test flights without the measurement equipment. But as you can also, or as you have seen before, actually the idea is to develop applications by doing this radio channel measurements and applications between communicating the drone and, for example, ground robots. So in this case, you can see this dog actually, which can be quite helpful and helping people if they need some assistance and so on. That's why I want maybe to stress a little bit more on application side, because this is, I think, actually the main goal or the final goal of our work, of our research work. But before we come to real application, before you see it in the city, in your city, like this kind of tandem of working of air units, ground robots and cars, and communicating with each other seamlessly and transmitting necessary information, we need to perform measurements and calibrate everything and develop channel models so that we can design wireless system. So here you could see that we had a transmitter and receiver installed on the cars, and we made these street canyon measurements, so where we utilize the same measurement equipment which we were showing you. So we have antenna arrays, we do the beam steering, so on both sides, on the receiver side and on the transmitter side. And here you can just see some examples of these like line of sight measurements when there is no blockage between the cars. But after we did these measurements on the ground, we made these measurements at ID2Move premises. This is actually a test area in Belgium, who's also partners and collaborators in this project. So we have done these aerial measurements, and here you can see that the drone flying with our equipment. Basically, we could obtain this similar results what we were just showing you between the cars. So now it's just a matter of processing and developing these channel models and designing wireless system. But of course, as I was saying, that it's very difficult to do a lot of measurements, so we cannot do millions of them. So what we want to do, we want to perform a reasonable amount of measurements, and then we want to calibrate the ray tracing software. In particular, in this case, you can see that we are utilizing ray tracing software by Remcom. It's wireless inside actually, and it allows us to simulate the drone flight path and also some position of the ground robots, ground units, whatever, and then we can see and simulate the communication between them. So this can be actually helping for us to develop statistical channel models. So here we also do these simulations in Kalasatama, in the area where we are interested to perform measurements on that street canyons. So maybe to summarize, we try to give you an overview of applications of drones, not all, some small part of those applications, but I hope you found those interesting, or maybe you didn't even know about those, or maybe you know even more applications, can say it in the comments. Yes, also about like fire measurement, waste detection, about aerial project and developing channel models by doing these measurements. And basically with these we are coming to the end of our stream, so hopefully you enjoyed it, and of course we would like to thank our collaborators and partners and sponsors who made this stream possible. Besides this, of course, follow for aerial project results, which will be coming in the format of papers and databases. So if you're interested in wireless channel modeling and so on, maybe I also would like to mention in the end that we are planning next streams, and just don't miss that one. That will be in a different format. It will be more like as a panel discussion, let's say, but it would be very interesting with the top experts. So just subscribe to us and stay tuned and don't miss the next stream. But from this moment, I would say yes, this is from my side. I don't know if Jarkko wants to comment anything here, but meanwhile I can check questions.
Yeah, if you check questions, then yes, the environmental challenges right now are a little too much for this particular demonstration we wanted to make, but I hope you enjoyed our stream, and I think Vasily has some questions by now.
Okay, so far I don't see any questions in the chat. Okay, there might be technical issues, so maybe no questions. Anyway, even if we miss them, of course we will come back and reply to all questions which are in the chat. And besides that, of course, you can use our contact information in the comment, which we will leave there. So, and ask us directly if you're interested in developing some applications or doing some research projects and so on. But thanks a lot for being with us today, and see you during the next stream.
Thank you.